of IoT networking in the country, and he's actually developed networks and set them up in Darabin, which is where we would be sitting. So today, he's going to tell you about all the projects that he's done and about his company that he's founded, and just talk to you guys about pretty much showing the real life implementation of what we do in this subject. So I don't want to take up too much time, so I'll leave it over to Tim.
Yep. Okay. Thank you. Hi, everyone. Now, just quickly, am I sharing my screen at the moment, Eddie?
Can't see it at the moment, but you should be able to. Do you have control?
I just bumped him to panelist, so I think
Okay.
that would be why.
Yep. So
Yep.
Tim, try now. You should have this share screen on the bottom of the screen.
Oh, okay. Unfortunately, I can't see my PDF.
If we make him a host, would that work? Oh, there we go.
Okay, can you see it now?
Yep.
Yes, we can.
Okay, finally. Emma, you're right. Third time's a charm. Okay, so welcome everyone to a bit of an introduction about myself and the company. I will be focusing on a couple of the different sectors of IoT, as well as the use cases that we've designed, developed, and implemented for customers. A bit about myself: I got involved with IoT by chance. I recognized the opportunity, and then ever since 2015, we've been pursuing this line of work. A bit about GON is that we are a licensed telecommunications operator in Australia, and we're looking at expanding our operation overseas and globally. So I'll just give a bit of a rundown into how it actually came. So here's a little bit about the idea that connected all of this together, how I'm even here. IoT was sparked by a need for change, and there's a lot of people around the world with different methods of changing different challenges that we have and how to challenge them face on. And all I can say is that we took the approach of actually doing something about it instead of focusing on finding or driving other people to. We started working with companies to procure greater efficiencies. We started working on certain projects where we were doing environmental monitoring since 2016. And what I can say is that unless you're prepared to leave your comfort zone, innovation and change can't happen. You do have to really tackle it face on. So we were created as an ecosystem to facilitate the engineers from telecommunications, IT, integrators, cybersecurity specialists, people at universities who are both on the teaching and the learning side, developers, etc., electrical engineers, city engineers, city-based, so the infrastructure engineers as well, from street lighting all the way to bridges, industrial, agricultural, and everyone in Australia and globally. So what's unique about IoT compared to other industries is that it's essentially an amalgamation of three different areas. And those three are telecommunications, electronics, and software. So the telecommunications is what we call the carriage. Electronics is the IoT device. Now, I just want to clarify that there are ways that people have been using the same term over and over, but in different ways. So Industry 4 is one example of IoT. Internet of Things is what IoT stands for. And you have all different types of digitalization, sensors, networks. There's a whole different category of ways that one can describe about tying up a sensor to an application and extracting data. But the common and most common one being used now is IoT. Previously, it was Industry 4.0. And every single IoT solution has a mix of all three. You can't have one without it, and they are all interreliant. Why this has been a little bit difficult for the industry to, and I'll go into this later as to why it's important to have an overview of the whole system solution, and not just a part or specifically focusing on a specific group, because that one area of focus can be the reason why the whole system comes apart from an architectural perspective. And we've had that happen a lot of times when we've had to go in to fix people's IoT needs. We realized that people were too isolated in what they were doing and not understanding the full idea of what it is that they were trying to do. And when it came to why we chose telecommunications, well, it's fairly simple. It's the most difficult to get involved in, and also it is the most scalable part and component of the three. Software can be argued that it's a lot more scalable, but there's a lot of players in that field, and we figured that we didn't want to go up against Oracles and IBMs and Microsofts in applications. So we figured we'd rather support them on the telecommunication side, and so far it's paid off very well for us. So just a bit about your industries. IoT will affect every single industry. There is no doubt about it. From medicine to, even yesterday, I was chatting with a colleague of mine, and I made the statement of 2 years ago, I said, we're never touching medicine, but all of a sudden now we have to start exploring into med tech. And there is new and daily features and opportunities are coming daily. And now is the time that IoT is sort of taking that big shift in paradigm. And some of the numbers that are coming out in utilization is mind-boggling, and I'll go into those as well. So the current snapshot of Industry 4.0 is becoming more and more accepted. People are realizing that a sensor can save them a lot of time, energy, and money. And it's not so much about saving costs or removing the amount of people they need to work for them. It's essentially about using those people to focus on an outcome as opposed to just collecting data. A sensor can collect data. You don't need to pay someone to go and physically collect that data. And large organizations are searching for these types of emerging technologies daily. One example of this that happened, I received a phone call this morning, and the first question was, well, have you got a sensor that monitors industrial noise? Well, why do you need that? Well, because we received a complaint that we were too noisy in our factory, in our warehouse. We want to prove that we're not. So when people start opening up to new technologies and what they call disruption, it's not really disruption, it's just evolution, I guess. But when they start opening up to this, they're more welcoming of new ideas. They're more transparent with people such as myself to actually fix a problem. And organizations are generally looking at doing this via two methods. One is they sort of do it in-house. They hire engineers, or they have the engineering knowledge, and they try to work out solutions in their own. And sometimes they engage professional companies to solve their IoT problems, such as GON or Telstra or some of the other companies. And then we we can make recommendations based on the best fit. And key to that is the actual word here, or the wording business as usual. Business as usual is a term in organizations that they say it becomes a part of daily operation. Business as usual. You send out quotes, you receive payment. It's all business as usual. And IoT is now not that much of a dream anymore. It's not a unicorn anymore. It's real. It's there. And companies are accepting of the benefits that it can bring for a very, very small investment. Now, some IoT devices can cost $20, but the data and the information that they're getting off it is far, far more valuable than the $20 investment that they've put in. So this one's just a little statement that IoT is revolutionizing the world like apps changed the internet, and they did. However, in this example with apps, it was done via a very, very intelligent device, which is your mobile phone. Sensors out there are a lot less complex. They're very, very simple. Some of them may only take one or two different types of data sets. And these apps that are emerging now is, imagine having 100 mobile phones out there in a particular site that you're a manufacturer, and you're able to receive the data off those 100 sensors telling you, is my production line working? Is my door open? Is the refrigeration working? What's the air quality like? Is there a fire? And these systems are now sort of becoming the norm, and they really, really are changing. They really are changing the way that a business can actually have greater transparency. I worked on a project where we knew every 15 minutes whether a refrigeration unit was working or not, because once that particular product went below or above a certain threshold, they weren't allowed to use it anymore for food safe reasons. And having that alert where, well, the fridge doesn't work, it got us out there, and we could actually have a look at, well, what was happening. Well, the door was left open. Oh, okay, well, that's not a big problem. But if your refrigeration stops working on a Friday night and people come in on a Monday morning, you could have hundreds of thousands of dollars worth of product that you have to discard. You have to throw it out. You're not allowed to sell it or use it. So everything that I've come across has always started off as a very, very far-fetched idea. From monitoring fires, and the particular use case that we are working on at the moment is exactly what you see, high voltage cables out in the Australian outback, and we are monitoring any line breakage or lightning strikes to check if there is any possibility of bushfires happening. Once we receive a report that something happened, we shut the power off on the main and divert the power via a secondary method. Now, Australia is very, very prone to bushfires, and it's very, very prone to a difficult response. We've got 25 million people over a very, very large area, and if something happens 400 kilometres outside of Melbourne, they may not have the number of people, they may not have the expertise to do it. So we have to look at intelligent systems to overtake what previously would have been done by either firefighters or a crew of electricians trying to fix a 100,000 volt or 20,000 volt, 10,000 volt power line. We can now do that with a cost-effective little electronic device. And this whole project seemed very far-fetched when we began it, but it's becoming more real because we've had our learning curve, and the partner who we work with in this particular case was very open-minded to suggestions and to criticisms. So once again, this is IoT. Off a mobile phone, we can visualize what is happening on a power grid to the authorized people. And this was something that was only possible via very complex computer systems that were linked up via satellites or via or within a control and command center that utilities have. And now it's becoming possible where it's basically on someone's mobile phone who's authorized to look at power grid performance. It's quite interesting, this project. I can't go too much into the application because there is some proprietary stuff, but that's the use case of it. So what I can say is IoT is big and it's getting bigger. One of my biggest concerns that I have regarding IoT is that we will not have enough knowledgeable people and resources when these large type of rollouts happen. And by large, I mean, mind you, this presentation was done for over a week ago, so that was previously then. But that particular morning, and I actually changed it to include that particular morning, I was discussing connecting 350,000 sensors with one customer who wants it in 3 months. Now, 350,000, let's have a look at the numbers here. Those devices cost $100 approximately in the last 10 years. Now, that is a very, very, very big number and a very big opportunity. And I want everyone to understand the scale here, because from our calculations, it would have taken 100 people working over 3 months to install those 350,000 devices for the particular use case, best case scenario. So when you start looking into ways that you're going to be looking at progressing on, whether you choose to go down the entrepreneurial path, or you're looking at going down the path of finding a job with a stable company, or you're looking at other options. What I can say is have a look at the companies and the industries that have the largest scale, because your performance as a person, your career will focus on the amount of opportunities that you have, and foremost, the amount of opportunities that you will able and capable of realizing and taking advantage of. Even though there are this many opportunities, you still need to go after them. Nobody will hand them to you. And the market out there is getting extremely competitive at the moment, because it is a big land grab. So just some numbers of the 5 top industries. I just ran a quick search just to prove what they're getting to. So in this current year of 2020, they estimate that there will be 1.37 billion utility sensors globally. And they expect that to be threefold in 21. So that is 300% compounding on 1.37 billion devices. Now, mind you, those 1.37 billion devices incorporate a device, an application, and they incorporate a telecom system or a communication system. So as you can see, it's not just about buying an IoT device and you've got one. There is a management side to it as well. And that is where your software engineers and your application engineers, engineers who may work for the utility company, will be required to help assist in managing and maintaining that system of what the utility is invested in. The second biggest growth area is security. So monitoring security systems, building, it could be personnel security, it could be any type of door security, suicide prevention. One use case that we've worked with was sensors that go onto the roof of tall buildings, and they alert the building manager if there is someone getting onto the roof who hasn't been authorized or they've broken the door. And generally what people were finding was that it took usually 15 to 20 minutes for somebody to take or jump off the building. And within that time frame, if they could get there, they were able to either restrain or talk to the person or get them down. So IoT has got a lot of different applications here. I mean, that's considered security, but that's also something beneficial to society. The third biggest one is government, with an approximate number of 700 million devices globally. And then we're hitting manufacturing with approximately 500 million. And then building automation is just a little bit under that of 440 million devices. Now, these are still going to be incrementally growing. So these are figures of 2020, 21 is going to be 3 times higher. So manufacturing, we're looking at close to 1.5 billion devices next year, while utilities will be approximately 4.2 billion. The numbers are just exponentially growing. So what is the role of engineers in IoT? And especially the mindset that's needed. I touched on it a little bit before, and I'm not an engineer. I mainly focus on the business side and the conceptual work, but I do work with a lot of engineers. And daily I can work up to about 15 different types of engineers. And one of the areas that I constantly try to tell my engineers who have a belief that this is their job and it's a channel or it's a vertical, and that's all that they need to understand. So if that's a PCB designer, or if that's someone who understands the structural integrity of bridges, what I have to always bring up is your role is a little one in a big ecosystem, and everybody needs to work together, but everybody at the same time needs to understand their place, because some of these solutions can be extremely complicated. I touched on the solution regarding the voltage, the high voltage monitoring. Now that was a very complex one, but luckily we had we saw the opportunity, we saw what needed to be done, and we had the expertise in-house as well. But high voltage is a very, very complicated area, and there are a huge amount of different types of engineers required to make that solution work. So that's where the ecosystem approach has to be viewed. You have to understand what the person asking you to do something wants. You have to understand what your role is. You have to understand what the customer's requirements are. And foremost, that's what pays everyone's bills. Keeping a happy customer, I give that a term as off the market. They're off the market. If they're happy, they stay with your company. You can grow, you can develop new products, you can develop new things. So that's the way that I look at engineers, that they're critical to the success of the project. And at the same time, if communication is not the best, it can bring the whole project down. So how we are building IoT and how IoT is being built around the world it's actually a very personal way that it's being built. Not a lot of people share the same and common ideas and mindset and needs of IoT. Some people have dogs, so they want to have a dog tracker. The person who doesn't have a dog doesn't need a dog tracker, but they may want to have a tracker on their mountain bike. And then we start looking at the different layers of businesses, different types of environmental. And I guess whenever people come to us with an idea, the first thing that I have to do with my colleagues is to actually understand what their objective is and what their role is within this IoT solution or this concept that they have, and then sort of guiding them. But finding out that key factor about what it is that they're trying to achieve, it can sometimes also be a very personal one. So having a very clear-cut, defined scope may not be off the bat accessible, because the person's thinking about how they want to do something, but then it's up to us to make sure that we provide them the correct advice and then provide them ways that they can actually capitalize on that opportunity or to fix the problem that they have. So when someone does approach us with a requirement in IoT, it generally begins with a gap analysis. So we have a look, okay, why do they want this? Why is this happening? What's the gap that they are trying to fill? And gap analysis can be used in a number of different ways. Generally with IoT, it's why are they trying to solve something with IoT, and is it possible? Sometimes there's cases that are not realistic, so we just tell the customer. So the second thing that we look at then after is, okay, well, what is the data that they are going to need so that they can fulfill what they want? Then we have to start modeling that data. Now, a solution idea can be quite complex. There's two different use cases there. We designed a solution that monitors beehive health, that we're working with Oracle, and we're working with Rooftop Honey just a little bit further down from Latrobe there in Heidelberg. And we've got a freight and logistics project with one of our logistics partners. And the solution idea has to follow, well, they may want to monitor the bee's health, but how do they do that? How is that solution going to actually operate out in the field? Is it realistic? Is it allowed? Because sometimes you're not allowed to do certain things when it comes to either design or with, and that they're regulatory type of applications. And then after that, we look into the system architecture, which usually is a device, a router or a gateway, something that collects a 4G tower, a 5G, coming Wi-Fi, Bluetooth. These are all systems that collect the information. And then that information in that architecture pulls it through to a routing server and then through to the application. And having a very, very robust system architecture that's not overcomplicated will always be better than an architecture that's complex or has too many variables. One of the things that we've realized that some of our design partners and engineers have worked with is assumptions. And assumptions are very, very bad when you try to do something out in the real world. And one of the assumptions is you have mobile coverage everywhere. Well, you don't have mobile coverage everywhere. You have it on your desk because you're in a city, but if you drive 200 kilometers outside of Melbourne, there are some areas even within 100 kilometers that there's no mobile signal, and that can mean disaster in a trial or in a pilot because the assumption was wrong. You do have to make sure that system architecture is fail-proof in your delivery and repeated delivery. Now that can also include having a totally separate architecture to even cellular towers. It really depends on the IoT use case. And then after that, our next step would be to go through what's called an MVP, a minimal viable product. We use the term MPV Some people use the term as a prototype. It's essentially the same thing. But being IoT, we have to use the MVP because we're looking at the whole architecture. Whereas a prototype generally relates to like a little electronic device or some type of electronics or some form of a physical tangible device. Bear in mind that we have the additional complexity of telecoms and software and application also on the device. And the MVP is designed to make it realistic for the customer, for us, for everyone, and just to see what we can iron out. After a general trial period of 2 to 4 weeks, the longest MVP trial that I've had is still going on. It's 2.5 years. We do an evaluation, and the evaluation criticizes everything. It critiques everything. Did we do the gap analysis right? Is the data what we need? Is the solution idea the best fit, or have we learned something new that we need to add into it? The system architecture, was a system architecture to standard? Did it fulfill the need of the actual problem? Did it fulfill that gap? That evaluation is very, very critical, because if you do not fulfill that evaluation to the best and highest degree that you can, from was the casing of the device good enough? Was the signal able to penetrate through the casing in the deployed item? Because sometimes we've had applications where just the casing and the design of the casing meant we were getting 1 kilometer and 5 kilometer differences on a device. So at that evaluation stage, it's really, really important to criticize everything that you possibly can before you move on to the finish. Now, the finish is when you do all of your post MVP and evaluation changes. So that includes your stress testing on, say, solar panels that are embedded on a device, through to mechanical design, any type of weatherproofing that may need to happen on the device. Is there a sufficient backup on the system architecture? Is there a fallback method if you lose connectivity, or if all of a sudden your application's down? Is the data stored somewhere and then uploaded when all systems are back online? And that finish is critical, because that is what your customers and the user will be looking at when it comes to the device and the solution being delivered. And after that, your next biggest hurdle is going to be marketing it. Why are you different? Who are you? Why are you better than this company? But I saw that with that company. And that is where all of those tiny, tiny little bits of details that came to knowledge in your evaluation, that is your ammunition. That is what will make you better than the others. And never undermine evaluation. And that is probably the time when a lot of people get their concept wrong, because they're so close to finishing and they feel that they've got something in their hand already and they can get it out there first and best. But things come very, very undone very quickly. And especially with the digital economy that we have and social media, if you don't have a very, very robust finished product that you're taking to market, you will fail. And evaluation is never an option to skip. You have to be the hardest on yourself at that evaluation time. If you can't be because of different reasons, get someone else to do it. And then afterwards, once your marketing's going well, you're left with a different kettle of fish, which is called the management. All of your breakdowns, all of your systems, all the monitoring, all the uptime, all the reporting, all the logging, all of the returns that you may have. So once you do have a concept, it's never just the concept and designing a product and you can sit back and and enjoy coconuts under a palm tree, you will be managing those devices out in the field and the applications and all the use cases as an expectation. That's what people pay that second and third part for, which is the comm system, the telecommunications component, and the application component. That is your ongoing management. If a device breaks, well, you have warranty and you have different types of, was it damaged by the customer or by faulty workmanship? They're minor compared to the other management systems that you do need to put in place. And I could go on about that for a very long time, but I think we'll move along. So here's a solution dive that we did. This is for a freight and logistics company. And here I'll go through some of the things and the struggles that we've had. So we were approached by a company, a very, very large logistics company, to track their unpowered assets, trolleys, little containers, etc. And we were asked to create a cost-effective, long life and rugged industrial sensor for asset management. Now, using our technology network, using our telecommunications network to report on the device's location. And this is probably a very, very simple use case. And it is, but it was not simple to do, because after numerous revisions and 3.5 years of redesigning in a moving environment, adapting, changing the structure. So this round disc is no longer what we use. We use an elongated one. And that flexibility of our mind to fulfill the customer's need has allowed us to close and start deploying this solution with our international partner. And this is what I want to sort of get back to, that in the previous slide here, I had all of these different factors that we took in to place, and we really, really had to look at the points of, well, how can we constantly make it better? And that led us to a successful implementation. But we were prepared to sacrifice our time, our energy, even income, just to get this right for the opportunity. And these opportunities are around now. As I mentioned before, the whole IoT industry is so big that not any company can do it themselves. And we're really only starting it. It's kind of like the .com era, if you've ever heard of that, where everyone was going crazy over websites and online portals and different things. And now we're having the same type of thing with IoT, where scale is coming into effect, and the companies that can adapt most to the requirement and stay true all the way without sacrificing any of the points mentioned above are the ones who are going to actually succeed out there. So I'll put this up about connecting. And this is our business model. This is our way we chose to fulfill ourselves in the IoT space, which was to provide the networks. And in mid 2019, GON made a number of critical changes to its business and what our role was. And this is part of that self-evaluation. You try something, it works, you absorb it. If it fails, reevaluate. There's nothing wrong with reevaluating. In fact, do it daily, sometimes even weekly. It's one of the best things to do. Just sit back and think, and never ever think that you're 100% right. You could be that 1% wrong, and that can cost you everything. Now, we changed our modus operandi, the way that we work, to being exclusively a network operator, and we help our partners now to find and and we introduce other partners to do the design work and all that. And that allows us to focus on the quality and delivery of the network. And as I mentioned before, GeoWAN is now a network operator, but we focused on that sector to allow everyone else to join, because we didn't want to be seen as competing with people. So when you're looking at going out there, you also have to find your place. What are you good at? And one thing I can say, and this is just with engineering in general and with other types of things, you have to work together. Nobody can do everything. And in fact, a lot of our competitor companies out there who have tried to do everything, they're the ones who are not doing the best in the market at the moment. So the second point that we reevaluated in 2019 was we lifted our customer criteria for cooperation. Before that, we were happy-go-lucky. We were happy to work with customers who, just came and they wanted an idea and a concept. But we changed that to a minimum requirement of $10 billion US turnover in order to get our time and our attention. We're at liberty to do that, and it's been successful for us. It may not be good for everybody, but we found that the customers with the money in the bank are the ones who are going to be able to pay our bills as well. And the frequency was important. We've set it down as a prerequisite that they have the turnover annually. Now, when a lot of the times when I talk with different views on engineering and different types of engineers, I do see the point of students and engineers focusing on big projects, and that's great. But those projects could only have a 5 or a 10-year life, and then you have to look at somewhere else, or you may be only required for the first quarter or half of the project implementation. And that's an example of why we went for the criteria of annual turnover of 10 billion, because that guarantees us that if we keep them happy, they still have 10 billion or more the next year, and the third year, and the fourth year, and the fifth year. And so far it's worked for us. But we didn't forget those other customers, because they're critical. They could have a 1 in a million project, and it could make us one of the biggest telcos in the world. And what we've done for those customers is we've created a distributor network that absorbs the additional work that we can't do. And delegation is very important in any type of design work or any type of solution that you'll be confronted with in life. Work together and ask for help. A lot of times things go wrong when I go back to that point when I said about assumptions. And that assumption could be that you're right, or that it's like that fixed 100%. Always ask, always engage, and always be prepared to change your mindset if you're wrong. But we still kept those customers happy. And we've grown the ecosystem, so our support structure has grown as well. So that, of course, freed up time for us to focus on delivery of projects. And when you're 100% focused on a project, it's so much easier. Everything happens. You're not having to drop what you're doing and worry about picking something up that you're not a part of from day one. And focusing on these types of points has allowed a lot of the other people who we work with within our ecosystem to realize that, hey, they're here to support. And that's something that you'll need as well when you go out there. You'll have to have a support structure. You'll have, I'm sure that you currently have mentors, or you have somebody who you can turn to for some guidance, advice. That doesn't necessarily have to stop when you start working or when you finish up university. That can keep going, but select who you work with, and make sure that both of you are allowed to grow. You don't want to have a type of a relationship with a mentor or with someone where you're like harassing them. You want to grow together and be okay with that. And the fifth point of everything is how easy. We've become a society where ease is crucial. They expect things to work. They want it to be easy, and we're using Zoom at the moment, which is a perfect example of this. Zoom has removed the teleconferencing requirements, but people didn't look at certain things because it was just easy. And now there's security issues and other types of things come through Zoom. But the fact that the entry to Zoom was so easy has let them raise I think it's 140 or 150 million dollars. They'll fix up the issues, but it's just amazing to see that because of ease and taking a concept that was already out there with Skype and with other conference mediums, were able to create something that was very, very simple to use, very easy to get a hold of, and then bang, everyone's using it now with the use. And that was some brilliant work there by them, I have to say. And I guess as a result of us changing around, we're now focused on delivering our gateway rollouts. We decided not to follow up with the council-led IoT networks and smart city projects that they were doing, only because of the time and the energy. It wasn't worth it for us. So what we did was we just put the network out, and we're focusing on the more, if they want to use it, they'll come and use it approach. That includes Darebin, Hume, Yarra Valley, Whittlesea, Cairns, Sydney, Kununurra in Western Australia, Alice Springs, Cradle Mountain. We've got gateways around Loxton, Adelaide, Perth, and that's what we've been focusing on, to make sure that our customers are looked after and waiting for the industry to kind of come around and mature. And I guess you always have to be looking at what's next. Now you're in university, what's next? And if you take the principles of what I put up here on the solution steps, where you always look at a gap analysis, data and all that, and quite frankly, what's next? Well, every time I sit with someone, there's always a mention of, oh, we should do this, or we could do that, or that would be a great idea. And you have to see those as all opportunities of what's out there and what possibly you can do. Now and going forward, I guess our next step was to grow. And once you leave university and you're out there, you'll have the same personal type of a mindset of, well, how do you grow? How do you get involved more intensively with whatever it is that you're particularly fond of, or that you have an interest in, or where you see a good opportunity? And the best piece of advice I heard regarding how to go forward in anything that you're doing, whether engineering or anything, is if you want it, you have to ask for it. First of all, you have to ask yourself, do you want it? And if you say yes, you want it, then you have to pursue it. Your next stage will be to ask other people. And that's how we were able to secure an investment to allow us to do and to grow our operations in the different areas. And we'll be seeking additional investment in the next couple of months as well. But just remember that this whole thing of IoT is an ecosystem. It's full of people. It's full of people with money. It's full of people with knowledge. It's full of people with skills. It's full of people with ideas. And one of the greatest things about IoTs is that you can relatively easily connect the dots and connect a solution. And providing that you maintain your integrity in the steps that I sort of listed there on how we do it, chances are you'll have a very, very successful career or product or business. And we have a look at the different numbers. See there on the bottom of the the page, and Business Insider is a very well-known publication, and they're releasing reports of 10 billion connected devices, and that's going to go to 40 billion by 2027. And the fact is, you don't have a lot of time before 2027. You may think you do, but you actually don't. It's taken us 5 years to get here, and that's the best part of 80% of that 7-year difference between now and 2027. So when you sort of do have a bit of some time to think amongst yourself, give that some thought, as in that $40 billion, how can you be a part of implementing 4 million of those alone? Because let's just say 4 million devices you implement at $100 a device, right? That's $4 billion. A lot of money. Doesn't come that easy. Sorry, 400 million. 400 million. So there's something that you can start thinking about what is it that you're going to do that's going to have the biggest impact. Because this opportunity with IoT, like I said, the previous one was the .com, and probably before that, I really don't know what it would have been, because .com's always referred to as the biggest point. But always make sure that you look after yourself on the bubble side, because .com bubble popped, and I think IoT is going to pop as well. But there's still a lot of devices going out there. There may not be enough players, and I guess that's my presentation and my talk about how we got here and what we do. And I guess if there's any questions there, I'll open up and Eddie can fire away.
We do have a few questions. We'll start with Aditya. He says, as an individual, what would be your recommendation to be an expert in IoT? How do I personally improvise my knowledge in this specific field?
What is his particular current knowledge? So what area does he work with? Like, is he civil engineering, or is he looking at electrical? Or
I'm going to have to ask him to get me that information. So Aditya, you can type that in.
Mm-hmm.
In the meantime, I'll jump to the next question from Brett Watkinson. You mentioned that there are some people or companies that you turn away that just didn't have realistic ideas when they came to you. However, you also mentioned that you can't really have ideas that are too out there. How do you distinguish between these sorts of things?
I'd have to say that volume and expectation. One point always is price. So when someone comes and says they want a device that is the size of a 50-cent piece and that has a battery life of 10 years and it doesn't ever need to be recharged and you can just dispose of it and throw it away, I'd say, well, you don't really understand IoT, because we don't run depleted uranium batteries. We run lithium. And if you want that amount of data, it's not going to come from that device. Something about the size of your fist, yeah, okay, maybe that will work because larger batteries, so that kind of works. So I guess a lot of the times when people's expectations are unreal about the physical properties of the technology is when we sort of walk away and we say, look, we don't think it's going to work. And generally what happens with those types of people is they're stuck in their, if they don't understand that evaluation process and that gap process that I discussed, their product by definition could be flawed, and that's the reason why we don't go there. We've had people trying to get us to put IoT sensors into off-the-shelf, very, very cheap plastic, and we said, look, it's not going to work because you expect the device to be outside. The plastic, from what we can tell, doesn't have UV testing, so we don't know whether it's going to last a week or it's going to last a year. We can't do it that way. And then the customer walked away, and we walked away, and we said, well, they didn't listen. We're not prepared to win them over. I hope that's a bit of an example of how we've had to sort of face these challenges.
All right, Tim, let's go back to the first question now. So I'll just repeat it and then I'll add the local context. So Aditya said, as an individual, what would be your recommendation to become an expert in the IoT area? How do I personally improvise my knowledge in the specific field? And then he said, I'm an electronic engineering student, but I have 5 years experience in the field of industrial automation.
Okay. You will be highly valuable in learning the whole sort of end-to-end system. Having the experience in industrial automation already and electronics, the communication component for you is only it's only really to the point of knowing what's expected of the wireless comm system, and its limitations and its benefits and all of that. Your value will definitely be in system tying that whole thing together, from a quality recommended sensor all the way through to allowing them and showing them how to tie up a particular, it could be, on conveyor systems. If there's any shaking, which means that the belt's offline, or it's not in line. So your value would be showing them a quality device that can fulfill their requirement, walking in, showing them how to tie it all up, and then deliver the whole solution to them. That system integration part is very, very highly in demand at the moment. And I actually believe it's one of the, like when we get very good, when we have access to, we do have access to some, but a very, very good system integrator is the difference between a total failure and a booming success. It's that person who interfaces between all three components and the customer. That's probably the place that you should focus on. And if you have a look at some of the companies out there who do a lot of industrial automation, you'll realize that they are very, very, very focused on customer outcome and customer happiness, like how happy the customer is with the end result. I would suggest going down that path.
All right, Tim, next question, and I'm going to just rephrase it a little bit. One of the students has asked if we can perhaps take this same question, but from a civil engineering perspective, I guess construction infrastructure perspective. And what I'll add to that question is that in Dubai, so basically Dubai right now is leading in terms of the number of devices per square meter in the world that are connected. So essentially the infrastructure, which was classical, let's say, concrete, glass, steel, etc., is now almost like living and breathing material. Essentially, every square meter is communicating to every square meter.
Yep.
So from your perspective, what does this actually mean for civil, structural, and infrastructural engineers in today's industry?
Okay, so everything that is infrastructure is an asset. So that's what we have to classify it as. And every single asset has a life cycle. Every single asset has an expectation on performance. Every single asset has an obligation, a contract to fulfill to the specifications on how it was built. Now, what I see a lot happening in the infrastructure, and there is a separate word for it, it's called infratech. And infratech is, to what Eddie mentioned, it's a living, breathing, talking world where a bridge and a guardrail and a wire, the tension wire, all communicate to each other when there's an impact or a collision. At the same time, a sensor may be placed at certain parts on a road, and when there's not enough light from the street light, it communicates to the street light to burn higher, or to have a greater amount of light coming through. And in regards to infrastructure, where IoT is going to play a role in infrastructure is already happening in certain asset management companies. And these types of asset management companies do surveys on roads, and they do sort of audits on street lights. They do audits on all different types of things that you can imagine. It's not just bridges and that. It can be, on road surface, gutters, manholes, high voltage power. So when you have a look at that civil engineering component, you're looking at how do you know, evaluate, and make an informed decision on that piece of asset, whether it needs to be fixed, whether it's just leave it and fix it in 6 months. And this is the way that these companies actually have designed and developed algorithms to, where they'll drive over a road surface, and they have a light system built into the front of the vehicle that scans how many cracks are in the road, how many potholes are, and then they send that informed decision over to the council and say, well, if you leave it as it is, it's going to deteriorate 30% in 3 months. It's going to cost this much to fix now. In 6 months' time, you're going to have to redo the whole road. And like Eddie mentioned, the amount of sensors going out there are constantly growing. Fault sensors in tunnels. We've had a partner who's worked on that, where they sense any geological movement in the tunnel, and they can be sort of informed that, hey, at this particular part, the sensors have indicated there's been some geological movement. Let's send somebody there to do an assay before, or it could possibly implode. And that's a very simple use case, but it's a very important one, because around the world, and especially now with the big metro tunnel that they're building here in Melbourne, there's going to be a lot of requirements for these types of monitoring systems. And once again, it's not just about building, it's about managing. IoT is there, not so much about the glory of building it and then you never use it. It's focused on that after management piece, which is essentially all of that auditing and savings that you can possibly get from having a system in place that lets you know when something's wrong or when something's right.
All right, guys, I think we have one more question. Matthew Corvetti. Do you see an opportunity for IoT in waste management systems for large scale or small scale construction and demolition projects? If so, how do you think it would be implemented? Or how do you think it could be implemented?
See, this is down the rabbit hole of IoT, because are you asking about the waste management of the actual site, or are you looking at the deconstruction of a site where you're looking at other different types of things, such as environmental sensors to say? If you're looking at IoT in particularly waste management, the only real thing you can focus on from my experience in waste management, and that is in the logistics side of the waste management, where you have 7 or 8, 10, 15 bins that show up to a site. They're designated wood, plastic, plaster, steel, and then you manage and operate those things that when the bin's full, you get a notification, and somebody from the wood yard comes and picks up the wood, and then the wood's not there anymore, and you know that it's arrived at the wood facility. Same thing with steel. So I don't know about. See, the cost of the IoT sensor is something that it makes it virtually impossible. Construction sites generally have a focus on either environmental monitoring, so noise, dust, anything like that, and they do a lot of security sensors, breach sensors and sensors of if anyone's loitering or moving around. Usually they're there to steal things. So I've had more experience in those types of things as opposed to the waste management of a building site.
Tim, quick question from Emma. Are you comfortable with the students reaching out to you via LinkedIn for additional information?
Yeah, that's fine. Yep.
Absolutely. All right, guys. So if you're keen to get in touch with Tim Cara via LinkedIn, I am going to give you his link here. So just might make it easier for you. So you guys can all connect with Tim. Oops, I sent it to Emma only. So all panelists and attendees, apologies. You should have the link there. So just copy that link and you should be able to add Tim. We are running a little bit out of time, and I know we've had Tim speak to the class many times before, and every time we've run over because the topic is super, super interesting. I guess you can have some individual chats with Tim if you like via LinkedIn and other platforms. Unfortunately, you can't meet face to face because this coronavirus is blocking us from doing that. But nevertheless, you should stay connected and use this as an opportunity. One thing that's worth mentioning, again, I've mentioned it time and time again, one of the main reasons why we do bring in external experts to talk to you about certain topics isn't just that you can get specific domain knowledge. For example, I asked you guys in the poll what your level of knowledge was regarding IoT. And it's good to see that a good chunk of you actually had reasonable knowledge in IoT. Some of you may have not answered. Maybe you're a little bit embarrassed to say I don't really know a lot. The point isn't to teach you about IoT. In fact, you could have completely not understood what IoT was about. What you probably should have gotten from it is it's connecting bits that talk to each other and building a business model around it. Essentially, that's where a lot of the innovation is. Taking a device and making it connected isn't that smart. It's what you do with the information that you collect from that that makes it smart and what you actually add value to. So this is where a lot of the innovation is coming in business models and essentially that angle. The actual technology itself, that's a whole other core study area on its own. So you should look into what this is going to enable in your particular field of expertise. And it's good to see that we had someone from civil ask the question and someone from the electrical, industrial background ask the same question. It's quite broad. So we don't expect you to become experts overnight. Tim, look, I just want to thank you on behalf of all the students that joined us this afternoon. It is a bit unfortunate that we couldn't actually do what we wanted to do. We have one student who's raised his hand, Jay Patel. I'm going to allow him to talk. He's asked to talk. Jay, can you hear us? You need to unmute your microphone. I think you've raised your hand.
Yeah, I can hear you.
Jay, go for it.
Like
you want to ask something?
No. I just joined it, so like I'm not aware about what to talk.
Okay, fair enough, mate. All good. All right, so Tim, thanks very much, mate, for spending this afternoon with us here and giving us a bit of an insight in terms of what's going on in the IoT world. Pretty exciting. Guys, if you have any more questions, feel free to reach out to Tim. For those of you that just joined or missed the presentation, this is recorded and it will be put on LMS so you can watch it in your spare time. Until then, thanks very much. Enjoy the next workshop. And Tim, thank you again on behalf of everyone.
Thanks, guys. Thanks, everyone.
Thanks, everyone.